4.4, and in 4.4 they start out with all this mumbo jumbo in the box. And what I want to point out is that, you know, it looks really confusing, and oftentimes if you either put some numbers in or draw a picture, it's less confusing. So I'm just going to draw, you don't have to do this if you don't want to, but I'm just going to draw a picture of what they're talking about here. So if you look at a coordinate axes, and you were to draw a circle on these axes, and then you were to draw a triangle inside of this circle. For example, maybe you were to draw this triangle. That's a right triangle. We've been talking about right triangles for a while. The horizontal distance is called x on that triangle. The vertical distance is called y on that triangle. And the segment that goes from the center of the circle to the edge of the circle is called a radius. So I'm just going to use the letter r. And then if you look at all of these things that are in the box, it kind of makes sense because that's what they're talking about. They're just talking about a right triangle. But instead of using like cosine to label the x part, and sine to label the y, and 1 to label the hypotenuse, or whatever other things that they're going to shove in there, they're using x, y, and r now. So it's the same right triangle we've been talking about forever. They're just using different letters. So that's what this whole box is talking about. Okay, so I'm not going to spend a ton of time on that. Notice how they gave us a point in this first example. When you see a point, you should be thinking about a triangle. Who said that? Thank you, Mason. A triangle is correct. I'm going to draw a triangle. You might want to write yourself a note. See a point, think triangle. I think we wrote that in our notes last week. So big idea. The point means, hey, I'm drawing a triangle. What quadrant would this triangle be in?
2.
2. You know that by the coordinates. So I draw a triangle in the second quadrant. Remember, the angle is always next to the origin. You always go from the point, -5, 12, to the x-axis and to the origin. There's a right angle over here. This is the -5 to the left, the 12 up. The hypotenuse is missing, so I would use the Pythagorean theorem to figure out that hypotenuse. If you figure it out, and you can do that on your own later if you want, I'm just going to tell you it's 13. Because 25 and 144 is 169, take the square root, and that's 13. And then they want us to write down all the trig ratios. So what they mean by that is, hey, what's the sine of my angle? So I look at my triangle and I go, sine is opposite over hypotenuse. So that means it's 12/13. Then I look for the cosine of that angle. And the cosine of that angle is the adjacent over the hypotenuse, which is -5/13. And then the tangent of that angle is the opposite over the adjacent, which is 12 over -5. And I don't really care where you put the negative, whether it's on the top, the bottom, or out in front.
-5.
And then if you want all the cofunctions that go along with these, you just flip the fractions. So the cosecant of theta is 13/12. The secant of theta is 13 over -5, or -13/5, whichever way you like to say it. And the cotangent is -5/12. So all you have to do in these cases is find the first 3, and then just flip them upside down. Remember that you guys are going to be responsible for simplifying. So if I ever run into a radical, I'm not going to simplify while we're working in class. You guys can do that later. Remember, move that radical to the numerator, take it off the denominator, that's simplified. So for example, if I have 1 over root 3, it's really root 3 over 3. No big deal. We talked about that last week. Questions about this one? So in the chart down below here, what we're going to talk about are all these signs. And what I want you to understand, first of all, is that the sign, remember when we're talking about coordinates, we were talking about, our coordinates used to be x, y, but now we talk about, instead of x, y, cosine, sine, oftentimes. So when you see the word sine, hopefully you are thinking about the y values. And when you're thinking about cosine, you're thinking about the x values. And then tangents and cotangents are y over x's or x over y. So you're dividing those values. So when you look at what's going on in a quadrant, and when I hand out the unit circle, they talk about the positives and the negatives. So in quadrant 1, everything is positive. In quadrant 2, which is to the left and up, the x values are negative and the y values are positive. And when you divide a positive by a negative or a negative by a positive, you get negative. In quadrant 3, both the x and the y values are negative. But when you divide a negative by a negative, you get positive. And in quadrant 4, the x's are positive and the y's are negative. And when you divide those, you get negative. And all this chart is trying to do for you is help you to think, okay, if I know what the coordinates are, I can tell what their sign is based on the quadrant that they're in. That's all it's reminding you. So like, this is not a chart I would ever memorize. I don't do that. I just remember, okay, x's are positive over here, y's are positive up here, and then everything else is negative. And if you divide them, if they're the same, it's positive. If they're different, it's negative. So I try not to memorize all that stuff. Next example, the tangent is negative 4/5, and the cosine is greater than 0. You might recall that last week when we were doing find these ratios and stuff, we figured out that the cosine is positive in 2 quadrants, right? 1 and 4. And the sine's positive in 2 quadrants, 1 and 2, and so on and so forth. And so there's multiple answers. So what I want to show you is that in this particular example, if I draw a picture here, and I talk about the tangent being negative 4/5, where is the tangent negative? Oh, let's see. If I go back over here into that table we just filled out, the tangent is negative in quadrant 2 and quadrant 4 from the previous chart we just filled out, 2 and 4. So now I go to this thing, and what that means is I have 2 possibilities. I could be in quadrant 2 for a triangle, or I could be in quadrant 4 for a triangle. Here are my 2 possibilities, but I don't want both of them. Okay? So how do I know what's going on? Well, they tell me that my tangent is negative. That's what tells me I could have my triangle here in quadrant 2, or I could have my triangle here in quadrant 4. So the tangent being negative means your triangle will be in quadrant 2 or 4. Well, how do I know then which one's in? If I look at the next piece of information that they give me, cosine greater than 0, that means my cosine is positive. Where's my cosine positive?
4. It's 1 and 4.
1 and 4, thank you. 1 and 4. Which triangle do you think I'm going to use? Quadrant 4. Why? Because both of them are true. So where the red and the purple are both true, that's where you want your triangle. So I don't want the light blue one, I want the dark blue one. Because both, the tangent being negative in quadrants 2 and 4, in the red is true, and in the purple, the cosine is positive, is true in quadrant 4. So I'm only working with quadrant 4 now. This is the triangle that I want. Here's my right triangle, here's my theta. The tangent's negative 4/5, which is the opposite over the adjacent. I use the Pythagorean theorem. 25 and 16 is 41. Take the square root. And that's my hypotenuse. And now I can do all the 6 trig ratios. So meaning, of course, I can say, oh, the sine of my angle is the opposite over the hypotenuse. Negative 4 over root 41. Don't forget, you're going to have to rationalize that. The cosine of theta is equal to the adjacent over the hypotenuse, so that's 5 over root 41. Don't forget, you're going to have to rationalize that. And then the tangent they already gave me, so I'm not gonna write that down again, but it's right here. They told me that. And then if I'm doing the other trig pieces, that means that my cosecant is just flip that upside down, so negative root 41 over 4. The secant is the reciprocal function for the cosine, so that's root 41 over 5. And the cotangent is the reciprocal function for the tangent, so flip the tangent upside down, and that's 5 over negative 4. So this is just like the previous problem we did in the very beginning. In this next chart, this comes right off the unit circle. I'm not going to actually do the chart with you, just like I haven't done some of the other charts. So I'm just going to write down unit circle. I'm going to fill in a couple